Welcome to Carlton's Math Corner. Today we're going to be discussing how to make an organized list to solve a problem. To begin, make sure that you have your journal ready as well as your vocabulary packet. Today our target is I can solve problems by making an organized list. So let's look at our first problem. SpongeBob is ordering a pizza. The crust choices are thin or hand-tossed, and I'm going to underline this information so that I can look back on it and I know that it's important information. The meat choices are pepperoni or sausage, and then the vegetable choices are olives, mushrooms, or banana peppers. Make an organized list to find how many different types of pizza SpongeBob can order. So when I order pizza, I know that there's always a variety of choices to choose from. And so in this case, it looks like when we're choosing a pizza for SpongeBob, we need to choose thin or hand-tossed. And then on top of that, there will be, just the regular sauce and cheese that looks like comes with the pizza. And then it says that we need to choose a meat choice, so pepperoni or sausage. And I know some of you order both, but in this situation it says or, so that means we can't put both of them on the pizza for SpongeBob. We need to choose one or the other. And then the last one is a vegetable choice. So we can choose olives, mushrooms, or banana peppers. Now, I know some of you may not like those three choices, but apparently SpongeBob really likes them. So we are going to basically look at the options that are given to us, and we're going to use them to see how many total options SpongeBob has to order a pizza. How many different types of ways can he make a pizza? And so first of all, what we're going to do is let's make a key so that we don't have to keep writing the same words over and over again. So I'm going to put T for thin crust, H for hand-tossed, P for pepperoni, S for sausage, O for olives, M for mushrooms, and B for banana peppers. And then I'm going to start making a list. Okay, so the first thing is I'm going to start with T for thin crust. So I'm going to think to myself, how many different ways can I make a pizza that has thin crust? So I'm thinking of what kind of meat can I put on it, and then what kind of vegetables. And so first of all, I'm going to stay as organized as possible with my list. So I'm going to start with, I'm going to make how many selections I can have with pepperoni on it. So T is for thin, P for pepperoni, and then what I'm going to do is I'm going to organize all three of the different vegetables. So I can have thin crust, pepperoni, and then olives, thin crust, pepperoni, and mushroom, thin crust, pepperoni, and banana pepper. So this covers all the options that I can have just for thin crust with one type of meat. But notice I have to also do a second type of meat. So I'm going to do thin crust, and now I'm going to make a pizza that has sausage on it. So we have thin crust, sausage, and olives, thin crust, sausage, and mushroom, and thin crust, sausage, and banana peppers. And so these 6 options right here cover all the different types, all the different selections I can have with thin crust pizza. But on the other hand, SpongeBob can order a pizza that's hand-tossed. And so I need to start all over and create the same options but put hand-toss in there. So I'm going to do hand-toss, pepperoni, and olives, hand-toss pepperoni and mushrooms, hand-tossed pepperoni, and banana peppers. And then start all over again, and let's use sausage as our meat. And so hand-tossed sausage and olives, hand-tossed sausage and mushroom, and then hand-tossed sausage and pepperoni. So if I count up all these different options, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And what I'm going to do is I'm going to make sure that my list matches the product that I would get when I multiply all these together. So for instance, notice I have different colors. So crust I put in yellow, and how many are in yellow? 2. So I am going to write the number 2 above that, and let's put it in red so you can see it. And then how many options are in blue? 2 again. So I'm going to put 2 above there too. So 2 options for meat. And then how many options are in green? How many vegetable options? Yes, 3. So I'm going to change this one to 3. And so we have 2 options for crust, 2 options for meat, and 2 options for vegetables. So what I'm going to do is I'm going to take those 3 numbers and I am going to multiply them together. So I'm going to do 2 times 2 times 3. And what do you get when you multiply them together? 12. And how many options did we get in our list? 12. And so I know that I have included every single option that I can have for ordering a pizza for SpongeBob. And so my answer is 12. So there's 12 different 12 different selections for pizza. Okay, so let's look at the next one. What if I have these 5 characters and they decide to compete in a 200-meter race? And they're all sprinters. And so we are trying to figure out how many different ways, and I'm going to underline this, so it says how many different ways can the characters place? Now think about when a runner places, if there are 5 people running in the race, what are the different places that they can place in? Well, they can place in first place, then second place, third place, and lastly, or not lastly, fourth place, and then lastly, fifth place. Okay, so if they can place in all those different places, now our question is how many different ways can the characters place? So, well, we have 5 different places, and I'm going to start a key down here. So S stands for Sonic, B stands for Bart, I stands for Isuzu, H stands for Hello Kitty, and R stands for Roadrunner. So we're going to start off, and basically what this is asking you is if Sonic places first, then Bart could place second, Isuzu can place third, Hello Kitty can place fourth, and Roadrunner can place fifth. Well, what if they're in a different order? What if Bart places first, Sonic second, Isuzu still third, Hello Kitty fourth, and Roadrunner fifth? And then what if I switch it again? What if I put, what if Hello Kitty comes in before Isuzu and Roadrunner? Or what if Roadrunner comes in before both of them? And so Roadrunner is in third place. Or maybe Hello Kitty is in first place, and etc., etc. How many different ways can you rearrange them in the different places, first through fifth place? Well, here is how I started. Okay, so first of all, I started off with a color for each character. And so the first character, I started off with S for Sonic. And so I put Sonic first in red. And then I basically started mixing up all the other characters. So do you notice I put Sonic first, Bart second, Isuzu third, H is Hello Kitty, and then R is Roadrunner. And so I did Sonic, Bart, so Sonic and Bart I kept the same, and what I did is I started rearranging all the other letters as many different ways as I could get. And I noticed that there was a pattern. When I started with Sonic, I noticed that I could rearrange the letters. Like I could put Bart in second place 6 different times with Sonic first, and I could rearrange the other ones. Then I did Sonic again, but this time I didn't put Bart second, I put Isuzu second, and I could rearrange 6 different ways to get Isuzu second. And so I just rearranged all these letters to get Isuzu second. And then same thing, Roadrunner I put now second, and I got 6 different times again. And then I put Hello Kitty second with Sonic first and rearranged again. And I just kept going until I noticed that there were 24 different ways for Sonic to be in first. Then I started all over again and I put Bart first, and then I put Isuzu first, and then I put Roadrunner first, and then I put Hello Kitty first. So I kept them organized by color and I kept them organized by columns. And I noticed that every single character, there are 24 different ways that I can arrange them for each character to be first. So 24 different ways for Sonic to be first, 24 different ways for Bart to be first, Isuzu, Roadrunner, and then Hello Kitty. And so all these different options, if I take there are 5 characters times 24 different ways, I found 120 different ways to place the characters. Now this one took a long time, and I will say most of your problems will not have such a large answer, but I wanted you to see how organizing really does help you help you to see like the patterns and help you not to miss anything. And so 120 ways. And one way to notice and to check your answer is, since there are 5 place values, or 5 places, I can actually take 5th place times 4th place times 3rd place times 2nd place times 1st place. And if I multiply all those together, I get 120. And it matches all of the ways what I got down here in my list. Okay. Our last problem. How many different phone numbers are possible for one area code if the first 3 digits are 268? In that order. So you have to start with 268, and then it says the last 4 digits are 0971 in any order. So I can rearrange these numbers. I can start with a 0 and then have 791. I can start with a 9, I could start with a 7, and so what I did is I organized it by that. I started off with 0 in red, then I started off with 1, then 7, then 9, and I noticed that there are 4 columns times 6 rows, so 4 times 6 is 24. And so same thing with there are 4 numbers, so 4 times 3 times 2 times 1 is 24. At this time, here's your ticket problem, and thank you so much for joining me at Carlton's Math Corner. I look forward to meeting with you another day.